Hi, this is Mrs. Yenny, and I'm going to review 1.2, Red and Blue is a Winner. And in this game we have two buckets. Bucket 1 has a blue, red, green, and yellow marble. Bucket 2 has a yellow, green, and red marble. And it costs $1 to play this game, and $3 if you win. And of course, based on the title, we know that to win we have to draw a red and a blue marble. So first of all, in question A, we had to predict and explain if we think the school will make money. And I'm going to say yes. And the reason that I'm going to say yes is because there's only one blue marble. So this is my thinking. It only costs $1 to play. That's pretty cheap. But to win, it's going to be fairly difficult because you're going to have to draw the blue marble in this bucket first. And after you draw the blue, you still have a 1 in 3 chance to draw the red, which are actually pretty good odds. So I would say yes, I think they will make some money. In question B, we have to make a tree diagram to show all possible outcomes. So remember from 1.1 review when we did the match no match game, we like to start with the word start and then show a branch for each of the equally likely outcomes from the first draw. And you can see we have 4 marbles, and each marble is equally likely to be drawn. So those are our 4 equally likely outcomes. And now what we're going to do is we're going to draw a marble from the blue bucket, or the second bucket. So to do that, I'm going to create 3 branches off of each of those marbles. And there's a yellow, a red, and a green marble. And regardless of which marble is drawn the first time, we're always going to have that yellow, red, green chances. Okay, so remember that the reason that we make a tree diagram is to create a list of all possible outcomes, or an organized list. So I'm just going to make that organized list right here. We've got a blue yellow, blue red, blue green, a red yellow, a red red, a red green, a green yellow, green red, green green, and a yellow yellow, yellow red, yellow green. And remember, the goal of this game is to draw a blue red. And our blue red, whoops, I wrote this one wrong. There it is. It's right here, blue red. So we can see that we have 12 possible outcomes, which is going to help us analyze the probability. And when we analyze a probability situation, that helps us find the theoretical probability, which is what we're going to do for C. So the theoretical probability of a blue red is just 1 out of 12, which is approximately 8%. Okay, question D. Suppose this game is played 36 times. Number 1, how much can the school expect to collect? Well, it's only $1 per game. And so if they play 36 times, or if 36 people play the game, they can expect to bring in or collect $36. Number 2, how much money can the school expect to pay out? Well, remember, the game theoretically is expected to have 1 winner out of every 12. And if we're expecting 36 people to play, that would be equivalent. The equivalent fraction to 1/12 is 3/36. In other words, we would expect 3 people to win out of 36. And every time a person wins, so that's 3 wins, times $3. Every time a person wins, you get $3. We would expect them to pay out $9. So did the school make a profit in this situation? Did the school make any money? If yes, how much? Well, yeah, they're going to make some money because remember, they took in $36. They expect to pay out $9, and that way they would make a profit of $27. Now this is all based on the theoretical probability, remember. So if the 36 people that play happen to be super lucky that day, then this payout amount could be greater, so that this profit amount could be lower. Or the vice versa could happen. Maybe these 36 people end up being super unlucky that particular day, and this payout could be less, and then the profit would be more. This is just what we would expect to happen based on the theoretical probability. All right, so let's find the following. Lastly, in question E, the probability of a green yellow. I'm going to look up here, and I'm going to just put a box around it. And this is specifically a green out of the first bucket and a yellow out of the second bucket. Because also in your hand you could hold a yellow-green, but what we're saying is a green first from the first bucket and a yellow out of the second bucket. So that's just one of those 12 outcomes. So again, it's 1/12. 1/12 or about 8%. The second one, the probability of not drawing a blue. Not drawing a blue. Well, we can see that our blues are right here. I'm going to go back to my organized list. And so there are 3 blues out of the 12. That means there are 9 that do not contain a blue. So that would be 9 out of 12, which reduces to 3/4, or is equivalent to 75%. All right, number 3, what is the probability of drawing a blue? Well, if we look back up at the buckets, we have a blue in bucket 1, but we don't have a blue in bucket 2. So of course, when we look at our outcomes, we're not going to have a blue. Blue is not going to even be an option. So we would say that the probability is 0 out of 12, or 0%, and in mathematical terminology, we would then say that's an impossible probability. All right, and the probability of drawing just 1 blue, well, all of ours here in the blue column of our organized list all have just 1 blue, so that's 3. Oops. That's 3 out of 12, which is the same as 1/4, or 25%. Alrighty, so that is 1.2, everybody. I hope you got that all corrected. Make sure that you ask me some questions at the Compass next week when you need those questions answered before you go on, and have a good one.